Google DeepMind's Genie 3 model is capable of generating richly interactive, realistic, and dynamic 3D environments in real time from simple text prompts. It represents a significant advance over previous AI-generated virtual worlds, marking a milestone on the path toward artificial general intelligence. Genie 3 is designed to build entire interactive 3D worlds that users and AI agents can explore and manipulate continuously for several minutes at 720p resolution and 24 frames per second. Unlike previous versions limited to 10 to 20 seconds of interaction, Genie 3 enables immersive and consistent environments that persist visually and spatially over time, allowing users to navigate and interact with the generated content much like a video game, but with worlds created entirely by AI. It is the first real-time interactive general-purpose world model capable of producing photorealistic, imaginary, or hybrid environments. The key features of Genie 3 include real-time interactive rendering by generating virtual environments frame by frame, maintaining 24 frames per second at 720p high resolution, which delivers smooth and continuous user-driven exploration. It supports extended interaction durations lasting several minutes, a significant advancement over earlier versions like Genie 2 that only allowed seconds-long experiences. Genie 3 also features emergent visual and spatial memory, remembering the placement and state of objects even when they are out of view, maintaining world consistency for about 1 minute and enhancing realism and immersion. Users can dynamically alter the environment by typing commands to change weather, add characters, or transform objects, enabling rich, controllable scenarios within the virtual world. Instead of relying on a fixed physics engine, Genie 3 learns how objects move and interact by observing outcomes over time, developing an intuitive grasp of physical cause and effect similar to human physical intuition. The model is versatile, capable of generating a wide diversity of environments, from highly realistic scenes to fantastical or hybrid imaginative worlds, making it applicable across many fields. How Genie 3 works technically. Genie 3 combines advances in generative video modeling with unsupervised learning and world modeling techniques. It uses an auto-regressive architecture, generating one frame at a time while referencing prior frames to maintain temporal and spatial consistency. By simulating and remembering its own generated environments, Genie 3 develops internal models of physical interactions and dynamics without explicit programming of physics rules. This self-supervised learning approach is key to creating coherent, believable worlds that evolve naturally over multiple minutes. Applications and potential uses. Genie 3 provides a dynamic playground where general-purpose AI agents learn adaptive behaviors through interaction with varied and logically evolving environments. It also facilitates the creation of immersive gaming and virtual simulations, allowing users to design and extend dynamic worlds via text prompts without the need for traditional manual 3D modeling. In education and research, Genie 3 offers realistic virtual environments ideal for exploration, experimentation, and scientific studies, especially in robotics and autonomous systems. It also supports scenario testing by simulating complex situations to safely and efficiently evaluate autonomous vehicles, robots, or AI behaviors. Genie 3 is currently in a limited research preview phase, available only to select academics and creators. Google DeepMind is using this phase to evaluate safety risks, refine the technology, and study its societal implications before any broader public release. Despite its impressive capabilities, Genie 3 has some limitations. Interaction length is still measured in minutes, not hours. Text and signage clarity inside worlds can be imperfect unless described clearly in input prompts. Some physical interactions may still exhibit artifacts or unnatural movements as the model continues to improve. If you found this video useful, subscribe for more future videos.